So I'm going to solve this question of odometer, and I've made this short presentation in which I'll talk about how we are going to approach this question, what is the problem statement, and of course the programming language that we're going to use is Haskell. So the problem statement says that you have to write a code for an odometer that has this constraint, and the constraint is like the readings that the odometer would display to you would have its digits in ascending order, and it would be like strictly ascending order. So 24, 79, 123, numbers like that are valid, and 21, 85, 88, 77, and numbers like these are not valid. As you can see, the digits in these are not in ascending order, and this is the constraint. Now you'll be given an input n, which is actually the size of the odometer. Or in other words, you can say it defines you, it tells you the number of digits that the odometer readings would have. So here I'll give an example. If the input is 2, then the odometer would have readings of 2-digit numbers like 12, 34, 59, etc. If it would be 3, the readings could be 123, 349, etc. Okay, so um, this is the part of problem statement itself. I've divided it into like 3 parts so that it's more clear to understand. So the code should serve the following functionalities of the odometer. I hope you know what odometer is. Odometer is just a device that shows you the distance traveled by the vehicle. So the first functionality should be that you have to generate a list of valid readings for a given input n, which is the size of the reading. Now valid readings are those, which would go from the minimum possible reading to the maximum possible reading, and it will keep checking if the numbers that come between that range have its digits in ascending order or not. So that is the only constant which makes a reading valid or invalid. From that list, you have to serve a second functionality, or you can say 2 more functionalities, which says that you have to find the Yth next reading for a given reading, and another function would give you previous Yth reading for a given reading. I'll give you examples for this if it is not clear right now. And the third important thing that you have to do in this code is that you have to find the difference between 2 valid readings. Now this is not simple subtraction. If reading 1 is 29 and the other reading is 34, then you cannot simply write 5, okay? Because you have to find the difference between readings, or you can say the number of jumps that you need to take to reach to second reading when you are at first reading, from the first reading. I'll give you examples for this. Now, if your input is 2, the list of valid readings would be this. If you look at this list, all the numbers here have its digits in ascending order, and rest, any number is not included in this list. So if you think a little bit, it would be like very clear to you how I'm starting with 12 and ending with 89. I would discuss more about it in the code also. So if I talk about a list of valid readings, this is how you'll generate a list. Like this is how it should look. When I talk about the next Yth or previous Yth, I'll give you an example. For example, if I ask, I want the second next reading to 17. So this is where 17 is. Second next would be like second jump, like 2 jumps from 17. So 1, 2, here you land. So 19 would be the second next reading to 17. Now here's the catch. It's not like 19 के बाद 20 नहीं है. You don't have 20 after 19 because 20 does not have its digits in ascending order. So now if someone asks you to give the like third next reading after 17, what would you give? 1, 2, 3. So the third next reading to 17 would be 23, like that. So that is the function. That is what the function should do. Similarly, if I ask you about the previous Yth reading or previous Kth reading, whatever you want to call it, suppose example I'll give you. If I ask you to give me the third previous reading to 89, so how many jumps would you need to go back from 89? 1, 2, 3. So the answer would be 69. So the third previous reading of 89 should be 69, and so on. The third thing was to find the difference, and now I think you would have gotten how to do that. It's just the number of jumps, like the difference of jumps between 2 readings. For example, this is 17, this is 23, the difference between jumps is how much? 3. Similarly, this is 38, this is 47. Take an example, 1, 2, 3, 4. So 4 jumps are there between these 2. So we'll discuss how we'll implement this in Haskell. Okay, so now I'll start writing the code. So if you remember the first question, the first function that was needed was to find the minimum valid value of the odometer for a given input n. So I'll define this simple function called mini, and I'll give it a type signature for it. The input type is obviously int because that is how the size of the odometer is defined, and the output would be int. So if you remember mini n, how would you define it? It should go from 1 to, imagine, 1 to n. Okay, think about it. If you have n is equal to 2, what was your minimum value, minimum valid value? It was 12, right? So it was going from 1 to 2. If n is equal to 3, then your minimum valid value was 123. Think about it. The first number of 3 digits, which has its digits in ascending order. So it has to go from 1 to n, right? This is not code, this is just okay. So this is like a list of digits, but obviously we can't use a list of digits. We obviously need a number, because if you use this, like if you use 1 to n, you'll get a list of digits. So if you write mini 2, you'll get 1 comma 2 and not 12. So you need 12, right? So you need something that converts a list of digits into a number. So how would you do that? I'll just define another function called digits to num. The type signature would be obviously a list of int, and output would be a number, which is int. So I'll simply define this, and I'll introduce you to a nice function which is fold L1, and we'll write it like yes, I'll write it like this, and here I would pass this and define it like this. I'll tell you why I'm doing this. So if you think about it, okay, so I'll show you how this function fold L1 works. I'll give you an example. For example, if I pass 6, 7, 9, what it should give you is 679, the number from the list of its digits. But how fold L1 would work? Now here what would happen is that y would become 7, 9, and x would be 10 into 6. We get 6 from here, like the first element. So 10 into 6 plus the first element from y, which is 7. So now the value of x would be 67, right? Now 67 would be the value for the next call. So this is kind of a loop, and 67 would now be passed here, okay? And now what would happen is, now y would be only 9. Now 7 would go here, so, and x would be 10 into what? Yes, 10 into what we had. Now the next call, the next value, 10 into 67 plus the value we have over here with y, 9, right? So we get what? 670 plus 9, which is 679. So we got the required value, and this is how this digits to num would give you the number from the list of its digits, and that's how fold L1 works. Let me remove this. Okay, now we have the digits to num function, which would convert that. And yes, so here we can use this. Here I'll write digits to num, and what do you think it would do? It would simply convert the list of 1, 2, 3, or whatever it is to a number. I'll show you how this works. I'll print this one. Okay, print mini 3. Let's take 3. I'll run this and I'll show you the output. So we got 1, 2, 3. Similarly, we can get 1, 2, 3, 4 for mini 4, 1, 2 for mini 2, and etc. So now I would write a Maxi function, Maxi, just like mini. The type signature would be the same. And now I would define it like this. And again, I'll use this digits to num function. But now how would we would obtain maximum would be different. If you think about it, it's very, very simple. It would be from 10 minus 9 to, sorry, 10 minus 9 to 9. I'll show you how. If you take Maxi 3, what should be the answer? 7, 8, 9, right? So you're going from basically 10 minus 9, like 10 minus, 10 minus n. This is a mistake. 10 minus n. 10 minus 3 is 7. So you're going from 7 to 9. Similarly, in Maxi 2, you'll go from 8 to 9. 10 minus 2, which is 8, 8 to 9. I'll show you how this works. I'll run it. Okay, 7, 8, 9. That's how we get the output. So these three functions are working. And now I would define a function which would do just the opposite of digits to num. This is converting a list of digits to a number. That function would convert a number into a list of digits. So you must be wondering why I'm doing this. I'm doing this so that I can convert a number into a list of digits and I can pass that list into another function which would check if the list is in ascending order or not. And that's how we'll know that the value is valid for the odometer or not. So we'll define just the opposite function of this, but we have another set of things to discuss here. Num 2 digits, I'll name this. I'll give the type signature, just opposite of digits to num. And here I'll define this. Now this would be something, I'll use an inbuilt function. You can see. I'll use an inbuilt function which is called digit to int. You can search easily for it. Digit to int. So I looked for digit to int. I knew it beforehand, but I'll show you the example. Like you can see here, it's converting the list of the list of characters into list of integers. The function digit to int is doing that. And what is map doing? Map is actually producing that list. Okay. So we are doing a similar thing over here. So we'll write over here map so that it produces a list. But we again need to write here show in order to make this work. And I'll show you how this works. I'll just show you this works. Num 2 digits. So you need to pass a number that can be converted to a list of its digits. So let's pass, suppose 689. This should give you 6, 8, 9. Let's see. This works. Now the next step would be to define a function is ascending. This we have to do. This is like a very important function because this is how we check if a particular number is valid reading or not. So obviously I'll pass a list of int over here because that's how we are getting from num to digits. And I'll get a Boolean value from here like true or false. Is this valid or not? So I pass this. Let's name the list of digits as DS. Okay. Digits kind of. And this is something important. Now here I'll introduce you, if you already know, I don't know, with ZipWidth function. This is a very interesting function. So here, as you can see, this is the ZipWidth function. So basically, ZipWidth function works like you pass a function, like here we have passed plus. You can also pass multiplication, or as they have done here, max. Then this is concatenation of two strings or lists. This is multiplication. Things like that. Okay. So this is the first argument, and this is the second argument. Okay. So what would happen is ZipWidth would combine these two lists and the corresponding elements would get added because here we have the plus sign. So 4 would get added to 2, 2 would get added to 6 and so on. So similarly, we are going to use it here. And here, since we need ascending order, so we'll use ZipWidth along with this. Just guess what should be the relation of left digit with right digit if the list is in ascending order. Less than sign, right? So this is how ZipWidth would work. But there's another catch, I'll tell you. So the first in a list that we pass is DS, that given list. Like if it is 6, 8, 9, the list would be 6, 8, 9. And the other argument would be nothing but tail of DS, which would be what? If the list is 6, 8, 9, tail of DS would be 8, 9. So tail function works like it would leave the first element and the rest of the element would be in the list. But here's the catch, like if you have 6, 8, 9, how would you make sure that each digit should be lesser than the digit just after it? So you should make sure of that, right? I'll tell you how this works. Now uh, for you to be sure of every digit, you need to make sure about all the conditions. So you need to make sure that all the conditions have to be true. Like this statement should be true for all the digits. So what can you do over here? You can write AND function so that it checks that all the conditions are true. Now I'll tell you how this works. For example, let's take 6, 7, 6, what was that? 6, 8, 9. 6, 8, 9. Okay. So this is what? This is DS. DS is equal to this. And what is tail of DS? Tail of DS, which is the second argument, is 8, 9. Now, if you talk about ZipWidth function, what would happen is you'll get a list of bool. As of now, you'll get a list of bool because that's how ZipWidth works. So ZipWidth would give you, now see, 6 is less than 8, right? So the first argument would be true, comma. 8 is less than 9. So the second argument is also true, right? And then you have the third argument, but you don't have anything here. So there's no thing about it. Now this AND function would make sure that you have all the values as true, because true and true would only give you true. Otherwise, you'll get false, even if there is one false. So AND function would give you one true. And that's how this would work. I'll show you some examples with this. 6, 8, 9 is obviously true. If you want, I can show. I don't know if you want or not. So it's ascending. 6, 8, 9. Okay. I'll run this. This should give me true. So true. If I pass something which is not ascending, like I'll pass 6, 4, 9. Let's see. This should give me false. False. So this works. The next thing I would do here is define a function that would give us the next valid reading when we are at one particular reading. Like with next valid reading, I don't mean here the next yth or previous yth. I'm not talking about that one. I'm talking about a function that would give you the next reading in order to get all the valid readings. So it would be simply int to int. And here I would pass n as the argument. Now, so here I'll use this function is ascending, and I would give a condition if is ascending. Okay. Num 2 digits. Now num 2 digits is what? It is converting a number into a list of digits. So I'm passing that into ascending because that's how it takes your input. And I'll do your n plus 1. So if this is true, then simply you'll write then n plus 1. Okay. Else next n plus 1. You might not be able to understand this right now because you might not realize the importance of this function. But I previously did not define this function because I did not know. Now the thing is, if you don't define this function, what would happen is, okay, let me share my presentation. There was that example. So what would happen is, like the next number of 19 would be 20, which is not ascending, so it would pass. But the next iteration in the for loop or whatever you do would be 20. So the next valid reading of 20 would be 23, and 19 would also be 23. and 21 would also be 23, and 22 would also be 23. So 23 would come almost like 4 times. And this is the thing which was going wrong, and that's why we need that function next. So it checks if it is ascending, then we'll simply pass n plus 1 so that it does not get repeated. Otherwise, we'll simply do this recursion thing next n plus 1. Okay? If you think a little bit more, you'll be able to understand. Now we'll try to define the first requirement which we had was to get the list of valid readings. So I'll define this function like valid readings of valid readings, and I would give the type signature as int to a list of int. And here I would define it like valid readings n equals, now this is something important. Okay, so here I would iterate from mini to maxi, obviously. So I'll go from mini, and this is like a list, and I'll concatenate it with next. So this is something important. I'll give a bracket here. Okay, next I, and now I'll define what I is. So okay, so here I have next I, and then this is like this line gives you a kind of condition, and you would get I from what? The list of mini to maxi. It is just like a for loop with an if condition in any other language like C++, Python. So mini n to maxi n. Okay. Now here I would write something that would make sure that this condition is checked. Okay. Or maybe you get the right next element and you don't repeat things. Okay. So here is next of, okay, I plus 1. This should not be equal to, this is not equal to sign next I. Okay. Okay, so we need brackets over here as well, and then I'll run it. We should get all the valid readings when the input size is 2, and we got that. We got it from 12 to 89, and that's how, you know, I copied this output and I pasted this in my presentation and showed you. Okay, now I'll define another function which is getIndex, and this would be helpful for us if if we want to get the next Yth and the previous Yth, or the difference between two readings. This would be very helpful. So I'll give the type signature like this. We are just passing the list of valid readings, this that we have got into this, and we want to get the index of a particular int that we are passing. So this is the list of valid readings. This is the integer that we want to know the position of, and this is the position that we would get. So this is the type signature, and now I'll define it like getIndex. I'll pass the list, which is the valid list, and I'll pass a number of which you need to get the index, and fromJust. This is another function which is actually included in data.maybe. So I'll include that data.maybe. I'll show you examples of that fromJust. So this is the example of fromJust. FromJust is actually, it would extract the number part from this just 1, just 10, etc. From just 1 you'll get, okay, from just 1 you'd get 1, from just 10 you would get 10, etc. So we get just 1 from the maybe functions, which I'll show you right now why I'm using fromJust. So fromJust, and here I would write, so for finding the index of I in list, this given list, I'll use another function called findIndex. FindIndex. The syntax works like this, and I'll pass the list. Okay, but the problem is that from findIndex, you would not get the integer form. You will get the just form. So you must be wondering why I'm using this fromJust function. I'll show you why I'm using it. So if I write here getIndex and I'll pass the list, suppose valid readings valid readings 2. This is what we can get, this is how we can get the list. And suppose I want to find the index of 14. So as you can see, the index of 14 is what? 0, 1, 2. So I'll write here 14. We should get that. But the thing is, I'll remove fromJust and show you why I'm using fromJust. So I'll run this. Okay, and here the data should also get changed, because just 10 is not of data type int, it is of data type maybe int. Now I'll run this. That is why this error crept in. Okay, so as you can see, we are getting just 2. The output is just 2. We should get only 2 written over here, right? That is why I was using here fromJust. And now when I use fromJust, you'll see how we get only 2. Oh, okay, I have to change the type here. Forgot to do that. I'll run 2. And that's how we get this function. Now the code becomes really easy. Now you only have to implement the next Yth and the previous Yth reading. Now we have defined this next reading function, and for this you'll get 2 inputs, n and y, like how many jumps that the user wants to know. Also you'll get the first reading that is required, as I showed you the example, and I've written this like this. Now the valid readings n would give you the list of valid readings for a particular size. This 2 exclamation mark would be like, as you write in Python, if there's a list, suppose there's a list. If you want to know the element at a particular index, what do? You write list I. So you get the element that is there in ith index, right? So exclamation mark, twice exclamation, double exclamation mark works like that only. So what is the index that we are passing over here? So this is the index. I'll show you what is the index. Now this thing is the index mod y plus I. Now y is the given index, like in the index we get of reading 1. Now where I, we have defined this over here, where I is get index valid readings n, r1. So r1, you'll get the index of r1 in valid readings n in I, the variable I would store that. So that index plus y would give you the Yth next index, right? And you'll pass that, and you'll divide that with the length of this list, so that you can take care of the corner cases, and that's how you can get easily the next Yth reading. And similarly, we'll define the previous Yth reading. The previous Yth reading is very similar to next Yth reading. The only difference is that here I have I minus y, which is very obvious. So now the only function which is left is the difference between the readings. And obviously by now you must have easily known how would we do that. So I'll define another function, which is difference between readings. And I would pass 2 values, which is the first reading, the second reading, the size of the odometer, and the difference between the readings, which is the output. So now I do define this. It was very similar to next Yth and previous Yth. The only difference is that you have to subtract. So I'll pass R1, R2, and the size of the odometer as we have defined. And we need the absolute difference between the between the indices of the two. So I'll do I minus j, and I'll define I and j over here, like where I equals, similarly, like we did in next and previous, get index. We'll pass a list, valid readings n. Okay, let me give a space over here. Valid readings n and another space. And I'll pass R1, and that's how we get the index for R1. Similarly, we have J. J would be very similar to this. The only difference is J would have R2, obviously. This is very easy to understand. If you write it on your own once, you'll easily understand. R2, okay? And I'll show you how this works. Our code is complete now. I'll remove this and I'll show you. I'll write all the functions to show you how all the functions are working. Okay, so I've written all the functionalities that was needed. The valid list, like the list of valid readings, the next Yth, the previous Yth, and the difference between the readings. You don't need these brackets over here. I just gave it like that. I'll remove all these brackets. There's no need of these brackets. So I'll run it and show you how this works. This is very, very interesting when you see it. Now the valid readings 2 gives us the output of all the list, all the readings that are valid for the size 2. And the next thing that I passed was next reading to 29, like the fifth next reading to 29. See here, we have 29. What is the fifth next reading to 29? 1, 2, 3, 4, 5, 38. So 38 is the answer. The next thing that I have written in the main function is third previous reading of 45. So see here, 45 is here. 1, 2, 3. 37 is the answer, and 37 is the third previous reading to 45. The difference between readings of 27 and 34, here you have 27, here you have 34. What should be the answer? 1, 2, 3. So you get 3. So our code is nicely working now, and it's very clear to understand. Yeah, okay. So we included 3 header files: data.list, data.char, and data.maybe. And yeah, we are done with the code. Thank you for watching.